Okay, so let's go ahead and start question number 5 on page 6, and which basically does the graphing of a logarithmic function, and this logarithmic function has a horizontal shift and a vertical shift. Which one do you think will be the, so we know that, okay, let's just analyze this for a minute. This is a log function, correct? Log functions, do they have horizontal asymptote or vertical asymptote? What do you guys think? Vertical, someone said vertical, perfect. It has a vertical asymptote. What is the equation of a vertical line? X equals to something. So my default is going to be x equals to 0. Yeah? Okay, so these are things that should kind of come into your brain because you'll need to do that. You'll need to remember those things. Which means that when I look at my transformed equation, which value will I be looking at for my new vertical asymptote? It's x equals to 0, so it has to be a x transformation. So it's going to be x. How has my graph shifted? This becomes my vertical asymptote. Does this make sense? Remember what I said when we did exponential? Look at the y value, because my default equation for my horizontal asymptote is y equals to 0. So now instead of y equals to 0, what is it going to be? It's going to be my new y value. But for logarithmic, it's going to be my new x transformation. So my new x transformation is x equals to -1. Is everybody clear? Yes? Okay, all right. Because this is important. For you, unless you know the asymptote, you won't be able to graph. Unless you know the asymptote, you won't be able to graph. So so let's see how we are going to do the rest. I just want to get this out of the way. So let's write this. Asymptote is going to be x equals to -1. For now, we'll just write that. And then we'll do the other stuff. So the parent, okay, so remember what I said, you always graph a logarithmic function by going through the parent. My parent exponential function is y equals to, it has to have some base to the power of x. My base will always be the same base, so the base is base 3 to the power of x. Did everybody understand what I just wrote? Because that's important. Okay, I don't know why this is scratched off, but we need to write this too. So if the parent exponential this, my parent logarithmic is y equals to log same base x. Or you can even write it from here without the transformation. Without the transformation. What are the transformations taking place? Can we all fill in this line? What are the transformations taking place? Transformations, you read it just like for any other function. There's no stretch or compression. I do see a horizontal shift and a vertical shift. Can we write both of them? Alright, so now what we're going to do is, for us to be able to graph it, your step, okay, you do this in 3 steps. Step number 1, you write, step number 1 is parent exponential function. That's your step number 1. So you're going to take 3 values for the parent exponential function. So you're going to take -1, 0, 1 for y equals 3 to the power of x. So can we fill in the y values for the exponential? Please let me know if you got these 3 values, if you did okay with this table. Right? 3 to the power of -1 is 1/3, 3 to the power of 0 is 1, 3 to the power of 1 is 3. And then step number 2, switch. x and y. And you notice that we are not yet done the transformation, but that's okay. We'll do the transformation as step number 3. So all you're doing is switch. So 1/3, 1 and 3. And then -1, 0 and 1. This is how you would graph. If you were told to graph just log base 3 of x, this is what you would do. If you were told just to graph y equals log base of 3, this is what you do. But you're not. You're going to do step number 3, where you apply the transformation. So you do it in 3 steps. You do it in 3 steps. So what are the transformations taking place? X is going to be just x minus 1, right? Are we okay with that? So you're moving, even though it says x plus 1, you're actually moving 1 unit back. So the x is moved 1 unit back. So this one is going to be x minus 1. The actual physical movement, not what it's in the equation, right? But the y is the whole graph is moving 2 units up, so y plus 2. So all you're going to do is take the x values and subtract 1 from it. Take the y, add 2. So how do you do this? So 1/3 minus 1 is how much? 1 minus 1/3 is 2/3 basically, except it's going to be negative 2/3. Everybody okay? Can we do this for, and then let's do the 1, 2. So -1 plus 2, how much is that? Everybody okay? Alright, can we finish the rest of the table just so that you get practice on doing this? Okay, did we get these? So this one is going to be 1 minus 1. Oh, it's frozen, thank you, yeah. Yes, yeah. Yeah, did we all get this? Okay, awesome. Now it's our job to, now this is what you will graph. Step number 4 is to graph. This is what you will graph. This is what you will graph. Okay. So I'll always start with graphing the asymptote. So my asymptote is x equals to -1. It's a vertical line. Okay, so did we all mark these 3 points? Is that part okay? So just mark these points and then I'll tell you how to graph it. So the way you want to always the way you want to graph it is you connect the 3 points that you have coordinates that you have dotted, connect those, and then on one side you want to, the side that has the asymptote, you want to go towards the asymptote hugging it, the other side just grows freely. The other side just grows. So connect these 3, where's my asymptote? So keep your eye on the asymptote. My asymptote is there. Keep your eye on the asymptote. So connect these 3 points and get closer and closer to asymptote, hugging it, but not really touching it. On the other side it just grows freely in the direction. It's slowly increasing, so it will continue to increase. So remember, yeah. Okay, so good question. So this is going back. So as soon as I look at it, I try to look for the asymptote. This is a logarithmic function. Logarithmic function, what should come to your mind is that it has a vertical asymptote. Exponential have horizontal, logarithmic have vertical asymptote. Vertical asymptote. What is the default equation for a vertical line? Vertical line is always, it goes through an x, it's always x equals to something. So it's x equals to 0. That means you're looking for the x shift. X shift is 1 unit back, so therefore it is x equals to -1. So it's always a new x value. Whereas for the logarithmic, let's go back, for the exponential, let's just go back because it's important. So this is here we go. This is an exponential graph. Exponential graphs have horizontal asymptote. Everybody good? Right? Because exponential e comes before this one, so it's a horizontal asymptote. Horizontal line. What is the equation of a horizontal line? It's y equals to something. The default is y equals to 0. That means you're looking for the y transformation. What is happening to my y transformation? It's moved 2 units down. So the y transformation, that is why my horizontal asymptote, because this is log, is y equals to -2. Yes? You're okay? Alright? So always keep in mind, that's the first thing you will try to find when you're trying to do a exponential or logarithmic graph. Okay. We're going to practice one more and then the class will be done. I know it's been a long class, so I will let you guys work on this by yourself. We will do number 7, except let's make it positive. Like I said, I'm not a big fan of reflection for logs and exponentials, so let's go ahead and do number 7.